Hey class, this is Mr. Roberts, and I'm going to go through the Chapter 2 test. Again, please fast forward, just look at the parts, the bits where you have some questions or concerns. I'll try and point out some of the places where I think you might be making errors, and I have some evidence that because if you made these specific errors, especially on questions that were multiple choice, you would have selected the wrong answer that was there. So on this question, the first one, which was worth 2 points, the one thing that I saw that led to an error was the fact that we are subtracting this 3 times this quantity, right? So that means this has to become a negative 3x and a minus 6. So that was the one thing. You can look at it a couple ways. If you do this, you can leave that negative symbol out, and you can distribute the 3 to the x, and then you can also distribute the 3 to the 2. So that would be inside the brackets a positive 3x plus 2. But then this says we're going to take the opposite of that. So both of those have to be flipped to their opposites. So this becomes minus 3x minus 6. There's a positive 4x here, and then we are at 11, and on the other side we're going to just have 6 times x and then minus 30. If I collect up some like terms, you see I've got a negative 6 and an 11. Negative 6 and 11 is going to be a 5. And then over here I've got 4x minus 3x, which is very simply an x. And that was a positive 5, right? A negative 6 and 11 is a positive 5. On the other side, we've got 6 times x and negative 30. So I'm just going to choose to subtract an x from both sides. That's going to leave me with 5x over here, and that's going to equal a 5. Oops, and don't forget the negative 30. And then if I add 30 to both sides, I'm going to write this up to here. If I'm adding 30 to both sides, the two sides will become, left-hand side is going to become 35, and the right-hand side is going to become 5x. And then when we divide by 5, that becomes 7 on the left-hand side, and we're left with x on the right-hand side. So x is the number 7. That was the solution for our first problem. And depending on the period, most of us, first, second, or third period, most of the classes were getting anywhere between 82 to 87% of that problem correct. Let's move on to question 2. On the second question, we were asked to simplify this expression, and the thing that I like to see in your scratch paper, your scratch work, is this idea that we can create giant ones by looking for common factors. And I like to use that word factors because common terms, those don't make giant ones, and we've talked about that in class. But I can certainly take this problem and rewrite it in my numerator as 2 over 2 times 4. So what I did was I just broke up the 8 that was there, and I turned it into 2 times 4. In the numerator, we still have an x to the negative second, and in the denominator there is a single factor of x. This is a 1, right? So that's gone. And the other thing that we like to do is we know that we can multiply by 1 and not change the value of anything, right? So, and maybe you need some convincing of that, but if I have 2/3 and I multiply that by the number 1 in the form of 4 over 4, I get 8, then 3 times 4 is 12. I get 8/12. Well, if you ask, 8/12 is exactly 2/3, right? 2 times 4 is 8, 3 times 4 is 12. These 2/3 is equivalent to 8/12, right? I just changed the form of it, but I didn't change its value. And if I looked at both of them as decimal approximations, they would both be 0.6 repeating. So let's come back over here. So the giant one that I would multiply by is I would multiply this by x squared over x squared. So I'm very clear and intentional here. I'm multiplying by 1. X squared over x squared is the number 1. I'm not going to change the value of this expression. I'm just going to change how it looks. And the other thing that happens is in my numerator now, you can see I now have this x to the negative second times x to the second. And that was on purpose. That was intentional. That's why I selected x squared, because this has created x to the 0 power with the two things that I've boxed in red. And anything raised to the 0 power is equal to 1. So if you look at it, I've got this giant 1 and then another 1. So my numerator ends up with just having the number 1 in it. My denominator has a 4, it has a single factor of x, and then 2 more factors of x. So that's a total of 3 factors of x. So my denominator is 4 times x to the 3rd power. So this is the answer that we were looking for. And depending on the class, it looked like 83 to 88% of you got that correct. And some of the answers that were selected that were incorrect, definitely I could see the errors and where it would lead to those. So if you got an answer that was not correct, like look at it and try and figure out what were you thinking, what did you do, where did your process break down. Let's move on to question number 3. Question 3 also asks us to simplify this expression, and is worth 2 points. If I go back just fundamentally, what does it mean to raise something to a power, right? Inside here I've got x to the 3rd. That means I have exactly 1, 2, 3 factors of x. So that's what that means. And you can see that this entire expression is being raised to the 2nd power, right? So what does that mean? That means that I have exactly 2 setups of exactly this same thing. So one way I can look at this is I can go ahead and write out, especially because this number is small, I can write this out and just kind of help me figure out in the future what's going on and maybe some shortcuts. So I can write 4x cubed y, and then another one exactly the same, 4x cubed y. Well, when I look at it, I see that I have 1, 2 factors of 4, right? So I can say, oh, there's a 4 squared in my answer. And I also see that I've got an x cubed and an x cubed. That's 3 factors of x, and then 3 more factors of x. That's a total of 6 factors of x, so x to the 6th. And then you can also see that I have 2 factors of y squared. So this is potentially one of the answers you could write, and I think this was not multiple choice. Yeah, this was multiple choice, so you could have selected, you could have left that, however that wasn't one of the choices, so you would have had to pick something else. And the thing that you would have had to pick is when you square 4 squared, right, that ends up being 16. So 16x squared y to the 2nd is what we were looking for. Valid answers, right? You could have also, if you were typing this free response, I would have accepted 16y squared x squared. Oh, I'm sorry, these are x to the 6th. That's very bad. Hello, x to the 6th, x to the 6th y squared, x to the 6th. Either of these would be equivalent to each other. So don't lose the fact that that's a 6 right there, Mr. Roberts. So, yeah. But it was multiple choice, so the only one that you could select that was available was this one, 16x to the 6th y to the 2nd power. Kind of note, when you look at this, right, you can see, oh, this was y to the 1st, whoops, this was y to the 1st, and this, 4 to the 1st and a y to the 1st. So you can see when you're raising a power to another power, right, 4 to the 1st, it's not really a power, it's just 4. But 4 to the 1st squared does give me 4 squared. X to the 3rd squared gives me x to the 6th, and y to the 1st squared gives me y squared. So you can see what's going on with this in terms of a shortcut, right? 1 times 2 is 2, 3 times 2 is 6, and 1 times 2 is 2. All right, let's move on to question number 4. Question 4 also asks us to simplify. This is worth another 2 points. And this is pretty straightforward. When I look at it, I can see I've got 2 factors of x and 3 more factors of x. So that's for a total of 5 factors of x, right? That's x times x and then x. So there's a total of 5 factors of x. So I'm just going to go ahead and write the number 2, and then I've got x to the 5th power, and then I've got 4 factors of y, right? Oh, get back up here. 4 factors of y, which is y, and I could put green dots, y. And then I've got 1 more factor of y. So you can see that's also 5 factors of y, so y to the 5th. And this was a response that you had to type, and I certainly would accept a lot of variations of this. Some of you perhaps maybe wrote the 2 in parentheses and left it. That would be okay. If you switch the order of the terms, so for example, if you had a 2 and then y to the fifth and x to the fifth, that's certainly okay because of the commutative property. And even you could have done this. You could have had an x to the fifth times a 2 times a y to the fifth. That's certainly equivalent also. So they're all equivalent, just kind of good form though. It's very nice to have numerical coefficients up front. And then I generally tend to put my variables in alphabetical order. So I would probably write this as x to the fifth, y to the fifth. But there's certainly no requirement that you do that. Um, and then you could have the multiplication dots in between there. Um, so anyways, let's move on to question 5. Question 5 says, what is the value of f of negative 4? So you can see I have a function. The function's name is f, and it's being passed a value of negative 4. And the question is, when you see this, we're saying we are concerned with what is the output of the function f when I give it 4. That's what this notation means, right? When I write f of negative 4, the input is the negative 4, and the f of negative 4 represents the output. What is the output? And you can see the output for x, right, if I read this correctly, the output for f of x when I give it x is x squared minus 4 times x. So you can see here's my input, and every single place where I've got an x and what the output is, I'm going to just replace it with that. But I have to be careful with this sign, so I'm going to write down f of negative 4 is equal to, now I'm going to take the number negative 4 and square it, because x is getting squared and x is negative 4. So this is showing negative 4 gets squared. And then I'm going to subtract from that 4 times what x is, and x is negative 4. And I think some of you missed that the x was negative 4, and you ended up adding a 16 here. I mean, sorry, you ended up subtracting a 16 there. You didn't catch the fact that you were subtracting 4 times negative 4. So this becomes, right, negative 4 times negative 4 is positive 16. And when you subtract 4 times a negative 4, that becomes a plus 16. So the answer is 32. 32 is the output when the input is negative 4. In fact, I could write it like this. For the function f, if you give the function f the value negative 4, it will give you back the value 32. The output is 32 when the input is negative 4. All right, let's move on to question 6. Question 6 says, what input into f of x will create an output of 55? So it's a different question now. What we're told is we know the output is 55. We know the output is 55, right? We get 55 from the function, right? That's what the output is. Well, the function rule is 7 minus 3 times 2x and then minus 4. So my question is, I need to find the value of x. I need to solve this for x so that I will know the value of x that produces this output of 55. So to do that, we'll start by, I'm going to distribute this negative 3 to both of the terms, right? They're not factors, they're terms on the inside, and end up getting 55 is equal to 7, and then minus 6 times x, and then plus a 12. 12 and 7 is 19, right? So this is 55 is negative 6 times x, and then plus the number 19. So I now need to subtract 19 from both sides. And 55 minus 19 is 36, so we have 36 is the same as negative 6x. Again, always be kind of aware of what you did. So for me to jump from this line, right, to the line below it, what did I do? I took away 19 from both sides. And now I'm going to divide both sides by negative 6. Over on the right hand side, negative 6 times x divided by negative 6 gives me just x. because that negative, here's a giant 1, right? Negative 6 over negative 6 is 1, so I'm left with just 1x. And then the other side, 36 divided by negative 6 is going to be a negative 6. So that means that x is negative 6. So if I use an input of 6 or negative 6, right, when negative 6 is what goes into this function ends up producing an output of 55. And you can verify this, right? 2 times negative 6 is going to create a negative 12 minus a 4. Negative 12 minus 4 is negative 16. So I've got 7 minus 3 times negative 16. If I take 3 times 16, I get 48. And negative 3 times negative 16 is positive 48. So I've got 7 plus 48. And if I take the 48 and I add 7, I definitely get 55. So it's really nice, especially if you have opportunities to do it, is to take what you think is the solution, plug it in, and then just carefully verify that it's doing what you suspect. So I can see now that when I do indeed plug in negative 6 into this function, I get this output of positive 55. Let's move on to question 7. 7 says evaluate the expression given the following variables and their values. So we're given variables, a is 6, b is currently negative 3, and c is 2/3. And this just asks what is b minus a. So b is negative 3 and then minus a, and a is 6. And if I have negative 3 and I subtract 6, that's just going to give me negative 9. So this was negative 9, and I don't think this was multiple choice. This was what you'd have to type this response in, and there were several of you that did different variations. Like you would have typed x equals negative 6 or just type negative 6 the value. I like it unless the question really asks for more. Like if something that has to have units, put the units in there, but if it's just a value, just give me the value and move on. This is not negative, this is not negative 6. This is the problem. I'm looking at the results and I'm like really disappointed because it looked like very few of you got this correct, and I was really disturbed by that. Where the problem was on the previous one. This one up here with the output and input, only 42%. Only 42% of the class got this. So I hope you really look closely at this and see what's happening. Let's move to question 7. Question 7, the answer is indeed negative 9, and it turns out that 92% of you got that. So I don't need to be as concerned as I was. Like, how is it that only 42% of you got this right? Maybe my answer key is wrong, but no, this was negative 9. 92% of you got this correct. Now let's move on to the next one. The next one, only 78 about. Well, it depends on the period. One of the periods got 85% got it right, but this one says evaluate this expression. And it's kind of a little interesting that only 78% of you got this right. Several of you told me it was 0. There were a couple other variations here, but I look at this and I immediately am saying to myself, look, I don't care what any of this is, right? I don't care. I'm raising it to the 0 power. Therefore, I know it must equal 1. So it's completely immaterial what's happening inside. So I could take the a, which is 6. I can take the b, which is negative 3, and I can square it. Negative 3 squared is 9, so I have 6 plus 9, which is 15. A couple of you told me the answer was 15. I got answers of 15. But remember, this is that thing, right? This is the red box. It's 15, but it was that raised to the 0 power. So it has a value of just 1. So I mean, 82% is not bad, but my hope is that all of us can get this right. I want all of you to be successful with these. So let's move on to question 9. On question 9, same exact 3 variables, and I debated switching these up. I thought, let me switch them. I think, no, let's not do that. Maybe later they can look carefully and see if I'm changing these values. But in this problem, c is 2/3, so I'm just going to write 2/3. That's the c, plus
And you notice I didn't use parentheses there. That's because there's not a positive or negative. It's just pretty straightforward. I could put parentheses around it, but I've got 2/3 plus 7/3 and then plus a, and a is a positive 6, so I could just put this in. 2/3 and 7/3 is 9/3 plus 6. 9/3 ends up being the number 3. So I've got 3 plus 6. So what we were looking here was the answer of 9. And 87% on average for the three classes got that right. So that's an answer of 9. Let's move on to question 10. Question 10 asks for it says, find the equation of the line that goes through these points. So there's 2 points, and I'm asking you for the equation of the line that goes through those 2 points. On this problem, more of you got it right than not than this says, because this is not including the variations that I accepted when I went through and I manually were scoring things. But it looks like really only about 35 to 40% of us got this correct. So conceptually, right? I'm just going to sketch this. I saw many of you trying to do this on graph paper, and I think the problem was you were disappointed because it didn't land at nice lattice points, right? You weren't getting integer values for our parameters, m and b. They were fractions, so we have to deal with that. But just conceptually, if I was to sketch this, one of the points is back 2, down 1. So roughly here's this first point, and the other point is over 1, up 3. So I can see that I'm going to definitely have a positive slope, and I'm going to have a y-intercept that's somewhere in between. I know it's somewhere between 1 and 3, right? It has to be somewhere in between the 1 and 3. But so that's just for me to kind of just like, it's a way for me to slow down and kind of like look at what I'm getting and verify, is this making sense? So I know it's going to be a positive slope, and I can see roughly where the y-intercept should be. So now let's go ahead and figure out what the slope is. So I'm gonna go ahead and look at my delta y's first, right? So delta y goes on the numerator, and that's a problem for some of us because we're getting the reciprocal of the slope, right? Remember, slope we define as the rise over the run. This is the y-axis, right? So when we're looking at our rise, it's how much change we have vertically. And then that's a ratio that we look at in comparison with the horizontal axis. So if I look at this is the x-axis, right? And I'm looking at how much that changes over time. Oop, that's my delta x. So if we look at my delta y, I can see y starts at -1 and ends up at 3. So I would just write 3 minus a -1, right? And I can see that, yeah, that makes sense. There's a change of 4 units and it's increased by 4. -1 plus 4 more units would land me at this 3. So my delta y is 4 units. And my delta x is, let's see, x starts at -2. It starts at -2 and it ends up at +1. Well, if I'm going from -2 to 1, I would have to increase by 3 units, I think. So, and if I do it with arithmetic, I can see I've got the 1 minus -2. 1 minus -2 is 3. So my slope parameter is 4/3. This is m. And this is one of the 2 parameters I needed to find this line. The other parameter that I need, of course, is I need my y-intercept parameter, but we've got the slope parameter now. So to set out to find what b is, right, our strategy in class has been, well, let's look at an equation of a line in slope-intercept form, y equals mx plus b. And we know what m is, right? And we're trying to figure out this b. And if we knew m and b, we could just write down our answer, but we don't know b. So the strategy we've discussed in class is using one of our points that's on the line, right? For example, I'm going to use the point 1, 3, and I'm going to substitute those values, the x and the y value, into the equation. Remember, for the 1, 3, x is 1 and y is 3. So I'm going to take that y is 3 from that point and replace y with 3. My slope is 4/3, and my x value is 1, and then plus b. So you can see this is a equation now where the only thing I need to solve for is b. And so I'm going to do that by taking away 4/3 from both sides. So I've got 3 minus 4/3 is b. I'm going to turn the number 3 into thirds. And I'm going to do that by multiplying it by 3 over 3. Again, I can multiply anything by the number 1 and not change its value. I don't have to do that on both sides because I'm just multiplying that one thing times the number 1 and it doesn't change it. When I do that, I get 9/3, which is exactly 3, right? I do that, I multiply it by 3 over 3, and I look at it and it's 9/3, which is, I know is 3, so I didn't change that part, and the other term is 4/3. What's nice about this now is they're both thirds, and 9/3 minus 4/3 is 5/3. So 5/3 is b. So b is 5/3. My slope parameter m was 4/3. So my answer then, the equation of this line is y is equal to 4/3 times x plus 5/3. And I do have two very nice values up there that I can test it either with my calculator or I can just do the arithmetic. But if I were to plug in the number x is 1, I should get 3. And when I plug in x is -2, I should get -1 out of that. So that was the answer there. This is a process that we need to continue to work on, and I hope that by next test or the next one after that, everyone's getting this right, and it's nothing but a thing. Let's move on to question 11. Question 11 says, what is the slope of this line? Kind of interesting order, right? So this one's just asking for the slope, so we can back way off. This is going to be easier. We just need to figure out two things, and I think I colored the delta y green. I'll think about this. Maybe I'll always do this because green is like grass, and it grows upwards in my backyard. There it is, nice viscous, but not Bermuda grass. And then the red, right, it runs, and R and red. Run and red start with the same thing. I don't know. So if I look at this, it might help if I'll circle the green, and then I might circle the red and the red, right? So my change in y starts at 5 and goes down to 3. So I know that this goes down by 2 units, right? 5 to 3 is at -2. And my run starts at 0 and goes to 4. So I know that this run is 4 units. And if I just write down the rise over run, I've got -2 over 4, which is -1/2. It's definitely negative, it's decreasing. And that was the answer, right? -1/2. Several of you left it as -2 over 4, and that's fine. I gave you full credit for it. I do kind of like it if you reduce that. If you can reduce a slope, do it. Because it's easier to, you're communicating kind of more efficiently what that is. So go with simplified forms. But certainly I will take -2 for us as an answer. One of the problems that I saw is that many of you, right, if you see slope, you just can't resist writing this, right? And that's the slope. The problem is that's not the slope. And if that was the slope, well, that's never going to be the slope of a line unless x is 1, right? Because what it implies is that, well, I mean, if x was always 1, what it implies is that as x is changing, the slope changes, right? And on a line, the slope of this line is always the number -1/2. It doesn't change over time. I can be way down here and look at the slope for this little chunk. The slope is down, is a half, right? I can look at the slope up here for this chunk. It's always going to be down 1 over 2 units, down 1 over 2. And when you put an x here, you're saying, look, depending on what your current value of x is, the slope is changing, which is an interesting idea. I mean, you can imagine that if x was 4, right? If x was 4, the slope would be -2. And if x was 8, the slope would be -4. And if x was -8, the slope would be +4. So it's kind of interesting to think about a shape that could have a positive slope and then over time it ends up having a negative slope, right? So, but that's not a line. So be really careful and intentional. When I ask you for the slope, right, this is what I want. I want the slope. Um, that's the slope, because when you put the x in there and you're telling me that's the slope, that's interesting, but that's not the slope of a line. Let's move on. That's question 11. Let's go to question 12. So question 12, maybe it was good, maybe it wasn't, but this actually appeared, I think, exactly like this in a practice thing that I passed out or I distributed online. But it says find the equation line that contains the points found in this partial table. Again, so this one, I'm asking for an equation again. I'm not asking for just the slope. I'm not asking for the y-intercept. I want the equation. And in order to get the equation, I need to know my two parameters, right? Every line can be written in the form y equals mx plus b. Well, there is a notable exception. Vertical lines cannot be written in that form. So anytime you have a line that's vertical, it's going to have to be something like x is 7. Or x is 2, right? And those are just lines that go straight up and down. But excluding vertical lines, any line can be written in the form y equals mx plus b. And there are two parameters here, right? We've got this thing called our slope parameter, and we've got another parameter called our y-intercept. And if I know both the slope parameter and the y-intercept parameter b, I can write the equation of the line. This was close to giving me the slope parameter, right here, because when x is 0, I mean the y-intercept, when x is 0, right, this would be the value of b, except there's nothing there. And also the table's a mess. So let's go ahead and just look at this slope. I'm going to say I'm going from this point to here. I'm going from this point to here. So I'm going to use that to figure out my change in y and change in x. So I'm going to say I end up at 8.5. So I'm going to go 8.5 minus 10. That's my change in y. And I end up at 2 minus 8. That's my change in x. So I'm looking at 2 minus 8 is negative 6 in my denominator. And 8.5 minus 10 is negative 1.5. So this apparently, it looks like it's increasing over time because I've got a negative over a negative. So when I do this division, I'm just going to do this on my calculator, 1.5 negative divided by 6. I get 0.25. And I recognize that that's clearly a quarter, 1/4. So because that is my slope, right, I can figure out my y-intercept, kind of. Not exactly. And there's kind of a nice way to think about this. I could reorder this table. I need the 0th term. Here's the first term. I know the second term, right? So in this table, I can write down, 2 was 8.5. And now if I go back 1, I just have to subtract a quarter. So 8.5 minus 0.25 is going to be 8.25. And then 8.25 minus 0.25 is going to be 8. So that's kind of a nice way to just, I know this value 2, it was given to me on the table, so I can start there and I can just walk back the slope by subtracting the quarters, and I end up with a b, my other parameter is 8, my y-intercept. So what's the equation of this line? The equation of the line is y is equal to 1/4 x and then plus 8. It's totally fine if you wrote down 0.25x. I would say the majority of you did that got it correct. Actually, that's not entirely true. 8, 9, 10, 11. Looks like it's about 50-50. About half of you wrote it like this way, half of you wrote it as 0.25, and those are both correct. I will caution you, if you only wrote down 1/4 x plus 8, that's not the equation of a line, right? Because I don't know what you're talking about. It becomes the equation of line when it's like, your y's are equivalent to that. And without you writing that down, this expression on the left hand side could be any number of things, right? I don't know, maybe you thought this was y plus 3x minus 2. I don't know what that is. So when I'm asking for an equation, make sure you do give me an equation. And you've got an equation because there's this equal symbol in there, right? So y values are equal to 1/4 of whatever the x's are plus 8 more. Y is 1/4 x plus 8. All right, moving on to 13. So on 13, on the board, I had listed several giant ones, and the ones that I placed were, I think I said that 8 ounces is 1 cup. I think I said that 4 cups is the same thing as 1 quart. I'll just abbreviate that QT. And also I had up there that 4 QT was equivalent to 1 gallon. So um, the time thing, you had to come up with those giant ones on your own. But it says the football team's Gatorade container is leaking at a rate of 1.5 ounces per second. That's that's a lot. That's not a reasonable leak. Someone would notice that and do something about that. This is a ridiculous problem. I'll change the numbers for next year, I promise. Okay, so let's get past that. So we know we've got 1.5, we've got 1.5, whoops. We've got 1.5 ounces OZ per 1 week, per one, no, per 1 second. SECOND. This is like a massive water tank. This is not something that would happen in a gymnasium. It'd ruin the floors. Okay, so we've got 1.5 ounces leaking every second. So let's go ahead and ramp this up to our gallons. So I'm going to bring in the giant ones that were written up on the board. That first one I'm going to need the reciprocal of, right? I wrote down 8 ounces as a cup. Well, I want my ounces to go away, so I want ounces to be in the denominator. So I'm going to say 8 OZ is 1 cup. That's nice. The next thing I want is the cups to go away. So I know that if I have 4 cups, that's 1 quart, 1 QT. And now I want quarts to go away, and I know that if I have 4 quarts, 4 QT, that is 1 gallon. So this change right here is going to make it so that now the number is going to be ounces. No, the answer is going to be gallons per second, right? This, if I look across the top, the only thing I'm going to have is you can see just the dimensional analysis. These ounces form a giant one. The units themselves form a giant one. A cup over a cup is a giant one. A quart over a quart is a giant one. So we're left with 1.5 gallons per, and then our denominator is going to be 8 times 4 times 4 seconds, right? And I don't really care what that number is right now. What I need to do now is I need to get this to become weeks. So we're going to do more with it. And you know what? Let's collapse this actually into a thing. So let's go ahead and write this down. This is 1.5. I'm just going to write gallons, but my number in the bottom is going to be different. I'm going to have 8 times 4 times 4, which is 128. It's 128 seconds. So you can see what I've done is I've recognized that my only units left in the numerator were gallons, right? The only units left in my denominators were seconds. In my numerator, I've got the 1.5 times 1 times 1 times 1. In my denominator, I've got 1 times 8 times 4, which is 32, times another 4, which is 128, right? Let me double check that. 8 times 4 times 4. No, that's wrong. 8 times 4 is 32, times another 4 is 128. Yeah, that's correct. All right, now we need to get this to be not per second, but per week. So we're going to start with the seconds. I want seconds to go away, and I know that 60 seconds is equivalent to 1 minute. That's a nice place to start. Now I want my minutes to go away, and you can see the reason why I'll just make it clear. The reason why I put the seconds in the top is I want seconds, these unit seconds, to be in the opposite place of the seconds that I had below, right? So you can see seconds over seconds will make a giant one, and I'm left with now gallons per minute. And I'm just going to keep doing this. It turns out that 60 minutes is 1 hour. It turns out that 24 hours is 1 day. So I'm up to days now. So I've got gallons per day as my units. And the last one, it said per week, right? Yeah, per week. So I know that 7 of these things we call day comprise 1 week. So you can see all of these units now paired up really nicely, right? The minutes over the minutes are gone. The hour over this hour is gone. And then finally I've got this day over the day that's gone. So the only units that I'm left with in my denominator is week, and the only units that I have left in my numerator are gallons. So this is gallons per week. But then let's look at the arithmetic, right? So I've got in my numerator 1.5 times 60 times 60 times 24 times 7. In my denominator, I've got 128. And my units are gallons in the top, and in the bottom, it's a week. So let's do the arithmetic here. 1.5 times 60 times 60 times 24, and then times 7. So I've got 1.5 times 60 times 60 times 24 times 7. That gave me 907,200, and I'm going to be dividing that by 128. So divide by 128. And that gives me 7,000. It's a ridiculous problem. 7,087.5. And if you were to round that, just call it, 7,088 or 7,087. I took answers all in that neighborhood. And the units are for that, they are gallons per week, right? So 7,088, 7,087 gallons per week. So again, take a look at your answers, see what you got. If for some reason I missed yours and you had that number there, come talk to me and I'll make sure you get those points. Let's move on to question 14. 14 and 15 involve scientific notation. Scientific notation is always going to be a value in this form where we have this number that is multiplied by some power of 10. The thing about this number is it has to be, let's say that this number is y, just for arguments. So this y value has to be greater than, it can equal 1, it can be 1 or more than 1, but it has to be strictly less than the number 10. So it cannot be 10, but it could be like 9.99999, right? But just can be, it has to be less than 10 but greater than or equal to 1. So that's the value. So when I look at this, I can put a decimal place right here, 1.45. So that's satisfying the requirement for that first value, right? You can look at that is greater than 1, but it's less than 10. If I put the decimal after the 4, that's greater than 10. That's not going to work. And it can't be here because clearly 145 is greater than 10. So the decimal has to go here. And then the question is, like, clearly that is not this number, right? This number is much larger than that. So the question is, how many factors of 10, right? How many factors of 10 do I have to multiply this by to put it back where it came from, meaning the decimal point? The decimal point, of course, is always right here unless otherwise specified. So it's sitting right there. How many times do I have to multiply it by 10? And the answer is, well, there's 3 of them. 3 of them, that's 6, and then 7, 8, right? So if I multiply this value times a single 10, it's going to be 14.5. Times another 10, it's going to be 145. So that's 2 of them. And then I need to do that by 1, 2, 3 more, and then 1, 2, 3 more. So it's literally 8 powers of 10. So the answer is 1.45 times 10 to the 8th power. This is exactly the same. And I'm not sure if your calculator can, I think it can show that many decimal values. So it probably can display that. But it would have to be that number. A few of you wrote 1.45 and then you raised that to the 8th power. That turns out to not be this number that we have, right, at all. So it is 1.45 and then always times 10 to the 8th. Oops, not times 10 and then to the 8th. This symbol is available when you're typing these in, right? It's the multiplication button. So if you hit that, that X will show up, as opposed to hitting the X, right? And I took that. If you type the letter X which is the variable symbol, that's okay, but you should be using the multiplication symbol there. So it's 1.45 times 10 to the 8th. Question 15, there's a quotient here. I ask you to divide these two numbers, but I said I want you to write your answer in scientific notation. Well, the thing about this is these things in the numerator and denominator are clearly factors, right? There's no addition subtraction here. So because they're factors, I can look at this and kind of come up with some, not necessarily giant ones, but I can do some division separately. So if I take 189 and I divide that by 9, I get 21, right? So this produces the number 21. And then times 10. Well, if you look at this, I can multiply this by 10 squared over 10 squared, right? And this becomes 10 to the 5th power, because 10 to the negative second times 10 to the second is 10 to the 0 power, right? And 3 plus 2 is 5. Also, if you just do it with the shortcut rules for the exponents, you've got a 3 here and a negative 2. It turns out that 3 minus negative 2 is also 5. So it's 21 times 10 to the 5th. The problem is that that is not in scientific notation. So for it to be, the decimal would have to land right here, right? So that's the number 2.1, which is not the number 21. So I'm going to modify that by multiplying it by a factor of 10, right? So everything that I've written out, I'll double underline in blue. That's the number 21, and this is the number 21. And you can see I also have to bring down the fact that it was times 10 to the 5th power. So when I simplify this for the final step, you can see I've got the 2.1, and I've got a single factor of 10, and then I've got 1, 2, 3, 4, 5 more factors of 10. So the answer is 2.5 times 10 to the 6th power. I don't know why I wrote 2.5. It's clearly 2.1. It's 2.1 times 10 to the 6th power. So that was the answer we were looking for question 15. Only a few more to go. 16. It says a line has a slope of 5 and goes through the point 2, 7. What is the equation of said line? Well, that's nice. This is all pretty set up nicely for us, right? Y equals mx plus b. We're told that this is a line. So I'm going to be teaching you another way to do this shortly, right, using something called point slope form. But for now, we're just going to take this slope intercept form. We're going to take the fact that we've got an x and a y. We're going to take the y that we're given, which is 7, and we're going to write this slope value 5, right? Our slope is 5, so I wrote 5. The x value was 2, and then plus b. 5 times 2 is 10, so this is 7 is 10 plus b. If I take away 10 from both sides of this, on the left hand side I end up with negative 3, and on the right hand side I end up with b. So b, my slope parameter, is the number negative 3. So now I know both of my parameters, right? My slope parameter is 5, my y-intercept parameter is 3, so I can write y is equal to 5x minus 3. And just as a quick check, does that have a slope of 5? Yes, it does have a slope of 5. Does it include the point 27? That's a good question, does it? Well, if I put in x as 2, I get 2 times 5 is 10, 10 minus 3 is 7. Yeah, it is on that. That point is on that line, because when I take the x from that point, this equation gives me the correct y value. So that point lives on that line. So there we go. This is the equation of the line that has a slope of 5, and it will go through the point 2, 7. Question 17. It says evaluate the expression given the following variables and their values. So we're looking at the absolute value of something, the absolute value of a negative 4 minus b minus 7, and then plus the number 2. So I suspect, based on some of the answers that I saw, that some of us might be just, I'm not sure what happened, but if I evaluate what's inside of the absolute value symbol, like a negative 4 and a 7, that gives me negative 11. So the absolute value of negative 11 is what I'm looking at, and it's really nice to take and just write that step out, right? What the absolute value of what? Well, this is negative 11, so I'm looking at the absolute value of negative 11. The absolute value of negative 11 is 11, so we've got 11 plus 2, which is 13. So our answer is 13. And I'm wondering how many of you got that right. That one was What was question 17? 80, 83% of all students got that correct. Last question then, it says, what is the y-intercept of the line? So I suspect based on some of the answers I saw on this question, 40 only, wow, really? It says 40, only 42% of you got this correct. It says, what is the y-intercept of this line? So, wow, only 42%. So I got several interesting answers. Oh, no, 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 no. No, more of you got this right. Oh, not many more. 50% of you got this correct. So 50% of you got this right. It says, what is the y-intercept of this line? So not sure what happened, but I think if I was looking at the line y equals 3x plus 7, for example, right? You're used to maybe just seeing this number 7 and deciding, oh, the number, that's the y-intercept, right? Well, no, it's not. It's not the y-intercept unless it's in this form, right? If the equation's written in slope-intercept form, yeah, then that is the y-intercept. The problem here is that it's not there. So several of you said the y-intercept was 25. And then some of you did this step. You said, well, 5y is equal to negative 3x minus 25. And I got this as an answer. The y-intercept is negative 25. But it's still not in y-intercept form because you can see the coefficient of y needs to be 1, and it's not. It's a 5. So if I carefully divide both sides by 5, on the left-hand side there's only one term. When I divide that term by 5, I get y. On the right-hand side there's two terms, and I need to divide both of those terms by 5, so it's going to be negative 3/5 x. And then negative 25 divided by 5 would be a negative 5. So now I can fully see the y-intercept. The y-intercept is negative 5. Exactly in period 3, period 2. 18 of you got that correct out of 36, 50%. And the other answers, well, okay, there's another one that's right. You wrote out the word y-intercept equals 5. And then some of you wrote out the entire equation. I didn't ask for the equation, and when you write an equation, don't assume that I know anything. In fact, most of you are smart now at this point. You're realizing I don't know much, so don't assume I know what the y-intercept is, right? Just tell me. So I wasn't asking for the equation, I just asked for the y-intercept only. So your answer should be just negative 5. And if you would have wrote it out, y-intercept is negative 5, that's fine, but totally unnecessary. It's simpler for me if you just write the negative 5 there. So yeah, bottom line, I guess, is make sure your equation is in this y-intercept form right before you try to tell me what the y-intercept is, or slope-intercept form. Last equation, this says, what is the slope of this line? And probably the easiest thing for me to do would be to add 2x to both sides. If I did that, this is going to be a 2x plus 3 is y. And clearly, if two things are equal, I can just flip this over completely. If I run it, I can say, oh, therefore y is 2x plus 3. So I can see right here, my slope is 2, right? Slope is 2. And it would have been great if you would have just entered that. Slope is 2. Not as many of you got that right, and I think this goes back to the fact that you were telling me, Mr. Roberts, this is a variable slope. It's 2x. The slope depends on what x is. No, it doesn't. The slope is always 2. This is like you're bumping up against calculus here when you telling me that the slope changes over time. The slope changes over time if you have a curve, right? If you look at this curve, this slope is different than this slope, is different than, this slope right here. So on a curve, yeah, the slope is different as x moves along, but this is not what we have here. We just have, you're told that this is a line. What is the slope of this line? You can see the equation. It's clearly the equation of a line. So the slope is 2. That's what we're looking for. Anyways, I'm available at lunch if you want to discuss any questions that you still have questions about, not sure about. I highly recommend get together with your friends, look at this, talk about this stuff. Really, before we get up to the next test, it's good to kind of think about these things and then pick up some extra questions and practice, as you go through. We'll be doing more to show you how to practice using GeoGebra and some other things in class in the next week. So just and then let me know how I can help. This is Mr. Roberts. Have a great evening. Good work. I know there's more to do, more you've got to do, and I'm certainly ready to help you improve. I'll talk to you in class.